Hello guys, how are you all? Hope doing well, right? Okay guys, as we discussed in our last class, how to assign the absolute configuration. Guys, here see absolute configuration, RS configuration, both are same, so don't get confused. So as we discussed in our last class, how to assign the absolute configuration for the chiral centers based on the SIP rules and based on the positions of the priority groups. Okay, today we are going to discuss about the applications of that absolute configuration. So guys, today we will discuss all about absolute configuration. Okay, so applications of absolute configuration with the simple tricks. Okay, we will enjoy it now. Okay, right guys, let's see it. Yeah guys, before going to discuss about this one, everyone please listen the topic from the first to last, then only you can apply this concept, okay, to answer the questions easily. If you know this concept, if you do proper practice, okay, no doubt guys, within 10 to 15 seconds you can answer very easily, correctly, absolutely. Okay, right guys, see, everyone please take a pen and paper and do practice, listen well. Okay, right guys, let us see what are the applications of absolute configuration without wasting our time. Yeah, so guys, here see, this is which we discussed already in our last class. Okay, anyway, let me remind you once again how to assign the absolute configuration. So guys, according to the SIP rules, first we have to give the priorities to the 4 different groups present on the 4 chiral carbons. After giving the priority, what we have to do? Okay, we have to view the molecule from the first to second, second to third prioritized groups. So by observing the first to second and third, second to third prioritized groups, we have to see how is our I direction is rotating. Based on the direction of the rotation, we can assign the absolute configuration, and in which we discuss the 2 different cases. One is in the Fisher projection formula, another one is a wedge formula. So guys, in the Fisher projection formula, I told you this simple and super trick. Okay, that is, so based on the position of the 4th priority group, if the 4th priority group is here on the vertical line, if our I direction is rotating in the clockwise, okay, the configuration will be R. If I direction is rotating in the anti-clockwise, it will be S. And similarly, if the 4th priority group is there on the horizontal line, okay, if it is on the horizontal line, so if the clockwise rotation represents S configuration, anti-clockwise represents R configuration. I told you a simple thing to remember this technique, that is vertical is very good, horizontal is opposite, like that, simply remember it. Okay, this is in the Fisher projection formula. No need to do any kind of the changes in the positions of the group. Simply apply this concept, you can do it well in the Fisher formula. Similarly, in the wedge flying formula also guys, I told you in detail. So okay, view the molecule same as, so give the priority from the first to second, second to third, and third to fourth prioritized groups, and view the molecule, and based on the direction of the rotation we can assign absolute configuration. If the 4th priority group is there on the backside bond, that is with the dotted lines, okay, the clockwise rotation represents R configuration, counterclockwise rotation represents S configuration. Whereas if the 4th priority group is there on the wedge bond, that is called as a front side bond, okay, a thick bond, so the clockwise rotation is S, anti-clockwise rotation is R configuration. And in case if the 4th priority group is there on the normal bonds, I told you how to do the operation, that is rotation. So bring the 4th priority group either onto the front or backside bond, and based on the direction of the rotation from the first to second and second to third, okay, follow this trick, you can answer it very well. Okay, so this is what we discussed in our last class. Now guys, let us enjoy what are the applications of the absolute configuration. Okay, right. Yeah guys, here we have 3 important applications of absolute configuration. Number 1, we can identify the enantiomers, that is identification of enantiomers, identification of the diastereomers, identification of identical or same compounds. Because guys, if you see some questions in the previous competitive exams, okay, so you may have the questions like, okay, which of the following pair of compounds are the enantiomers or diastereomers or identical compounds, like that. Okay, very simple guys, don't get confused. Okay, I will tell you the simple and super trick to identify them with the absolute configuration. Okay, right, let us start how to identify enantiomers with the help of absolute configuration. So guys, what are enantiomers guys? Okay guys, here enantiomers are the stereoisomers which are having the non-superimposable mirror image relationship. Okay, enantiomers are the stereoisomers having the non-superimposable mirror images. Suppose guys, here if you take these 2 examples, see, this is one of the molecules. Okay, what is the name of this molecule? Yes, okay, just give the numbering 1, 2 and 3. So 2 hydroxy propanoic acid. Okay guys, here see, consider this is a mirror. So when you keep the mirror, what happens? Okay, this compound can form the image like this. Okay, so these two are the mirror images. Now let's observe that whether it is having the superimposable or non-superimposable relationship. That means, so just bring this molecule as it is and overlap on it. And see guys whether all the four groups are coinciding or not. No. So above the side carboxylic acid group, a carboxylic acid group, okay, will be coincide, and the methyl group will be coincide. And here hydroxy group will be overlap on the hydrogen will be overlap on the hydroxy group. That means, so here these groups are not coinciding. So if all the same groups are coinciding with each other on the overlapping, that will be identical compound. If all are not coinciding, so they are called as enantiomers. So enantiomers are the stereoisomers having the non-superimposable, that is called as a non-superimposability. Okay, so enantiomers having the non-superimposable mirror image relationship. They are the mirror image but non-superimposable. Such kind of isomers are called as enantiomers. Now let's see what is the relation between what is the relation at the absolute chiral centers and the absolute configuration between the enantiomers. Well, let's see that. Okay, so guys, here see. Now let's decide the absolute configuration for this chiral center. So for that, what we have to do, we have to give them priority. We have to give the numbering priority. How to give the priority, guys? Based on the sepals we have to give. So according to sepals, first to see the four different atoms directly present at the chiral carbon: oxygen, carbon, hydrogen, hydrogen. Whose atomic number is more? Oxygen atomic number is more. So oxygen containing this group will get the first priority. And hydrogen is least atomic number na, so it gets a least priority, that is fourth priority, and second and third priority left. So how to give the priority here? So guys, here since both are the carbon atoms, we have to go for the further atoms. Okay, already we discussed it in our last video, right? So anyway, so the carbon is attached with one double bond oxygen and one single bond oxygen. So double bond oxygen means two oxygens plus one. Three oxygens are present on this carbon, and here this carbon is attached with the three hydrogen. So oxygen atomic number is more than hydrogen, so therefore this carboxylic acid group gets a second priority and it gets a third priority. So after giving priority, what we have to do? So forget about the fourth priority racing group and view the molecule from the first to second and second to third priority raced groups. Okay, when you view the molecule from the first to second and second to third priority raced groups, first to second and second to third, our I direction is rotating in the clockwise. And where is the fourth priority group? Fourth priority group is on the horizontal. So in general, clockwise is R, but since fourth group is there on the horizontal line, horizontal is opposite. That means R becomes S. So here second chiral carbon is having the which configuration? S configuration. Same as give the priority also here. So here also when you give the priority, so guys, here as usual, okay, this is getting the first priority, hydrogen is getting the fourth priority. We decided already here. So this is second priority raised, this is third priority raised. Now view the molecule from the first to second and second to third. How is our direction is rotating? Anti-clockwise. So anti-clockwise is generally S configured. But since fourth group is there on the horizontal line, horizontal is opposite. That means S becomes R. So here it is having the 2R configuration. So guys, here see these two compounds. Okay, this compound, both are the enantiomers at a given chiral center, means at the same chiral centers of the two isomers. Okay, this is first carbon, this is second carbon, right? At same chiral centers of the two carbon atoms, we have to observe their absolute configuration. So at same chiral centers, okay, the absolute configuration will be reverse. Okay, such kind of isomers are called as enantiomers. Like this, we have to identify that. That means, so guys, here see the simple from all this discussion, what we observed is that, so that the enantiomers, in case of enantiomers, at a given chiral center, the absolute configuration will be reverse. Yes, guys, this is our observation. From this observation, we can make this statement. Okay, the statement, or we can say it as a trick. The trick is that in enantiomeric pair means pair of two compounds. Okay, the absolute configuration at same chiral centers will be opposite. It means in the one compound, if absolute configuration is a R, at the same chiral center in the another compound, absolute configuration will be S. So that is what we have to observe. So suppose here also, if you see that, okay, 1, 2, 3 prioritized group now. So this is first, second, third. So first to second, second to third, absolute configuration is in the anti-clockwise direction. Anti-clockwise means yes. But guys, here see the fourth priority group is there in the horizontal now. So horizontal is opposite. That means S becomes R. So here absolute configuration at a given chiral center is R. And in this example, so 1, 2, 3, 4. Okay, first to second, second to third configuration, our right direction is rotating the clockwise. That means it should be R. But since the fourth group is here on the horizontal line, okay, what happens? R becomes yes. So it is having the yes. So at a given chiral center, means give the numbering first. Give the numbering to the all the carbons in the parent chain. So after giving the numbering at the same chiral center, here this is second carbon is a chiral center, here also second carbon is a chiral center. At same chiral center, absolute configuration should be different. They are called as a enantiomers. Like this, you can observe the enantiomers. Simple, na? Very easy, na? Right. So guys, here now tell me guys, find out the absolute configuration of these two compounds and identify whether these two compounds are the enantiomers or not. Why? Because so guys, here easily you can identify that, okay, because okay, mirror image relationship is there and non-superimposability is there, so easily you can identify as they are the enantiomers. But guys, here see, so can you identify okay whether they are the mirror images or not? No, it will be difficult. In this case, what kind of isomers are these? Whether they are the enantiomers or not, how to identify? So just follow our technique, okay, to identify absolute configuration. Okay, let me tell you that. Okay, hydroxy group is the first prioritized, carboxylic acid is second, and this is third, this is fourth. Based on SIP rules only we are giving. Now view the molecule from the first to second and second to third. How is the direction is rotating? Anti-clockwise. Anti-clockwise is a yes, but fourth group is here in the horizontal. So horizontal is opposite. So S becomes R. So here if you give the numbering to the carbons, second carbon is having the which configuration? Okay, anti-clockwise is yes, but horizontal is opposite. That means R configuration. S becomes R like this. And in this compound, give the numbering. So 1, 2, 3, 4. Okay, now guys, here see 1, 2, 2, 2, 2, 3 is in the anti-clockwise. Okay, our I direction is rotating in anti-clockwise. Okay, anti-clockwise means yes, and where the fourth priority group is here on the vertical. So vertical is very good. That means anti-clockwise is yes. So here second carbon is having the which configuration? Second carbon is having the yes configuration. Now see, these are the both of the compounds having the same molecular formula, so therefore they are the isomers. So in these two compounds at a given chiral center, that means at the second carbon of the first compound and second carbon of the second compound, the absolute configuration is exactly reverse. That means these two are the having the which relationship? Enantiomeric relationship. Like this, in the pair of given isomers at a given chiral center, if the absolute configuration is exactly opposite, okay, those isomers will be enantiomers always. Okay, like this you can do. Not only these guys, you may take any number of the chiral centers in the two isomers. Okay, if at all the chiral centers in the two isomers are exactly reverse, they will be no doubt enantiomers. Okay, clear guys? Right. Now let us go to the another application. Yeah guys, here I am giving you one practicing question. So just for simply for the sake of practice, here I gave the different molecules, okay, like A, B, C, D. So all are isomers only because molecular formula is the same. So what you guys do is identify absolute configuration at the chiral centers and identify which are the enantiomeric pair. Here I am telling you the important thing while you are solving these kind of the questions. So guys, make sure to give the numbering first. So here see carboxylic acid and ester is here. Carboxylic acid is a king of function group, so it gets the first number 1, 2, 3, 4. Okay, like this you have to give the numbering. And here what are the chiral centers? Second carbon and third carbon are the chiral centers. So I find out the absolute configuration at the second and third carbon. Now here also give the numbering. So which will get the first number? Carboxylic acid. So 1, 2, 3, 4. Here also I find out the absolute configuration at second and third carbon. Same as here also, in this case also. So give the numbering. So carboxylic acid gets the first number. So right. So 1, 2, 3, 4. Like this you have to give the numbering. So it is must and most important. Always you should not see from the top to bottom. So you have to give the numbering in such a way. Okay. So now here at the second carbon, third carbon having the which absolute configuration. Same as here ester is above this side, carboxylic acid is below this side. So don't give the numbering from the top to bottom. From carboxylic acid you have to give the numbering. So 1, 2, 3, 4. After giving the numbering like this only, okay, just assign the absolute configuration. Now at same chiral centers, if the absolute configuration in the pair of any two compounds is exactly opposite, they can be enantiomers. So guys, here I gave the ABCD 4 compounds. So please assign the absolute configuration for the sake of your practice and identify which pair of compounds are the yes enantiomers and which are not enantiomers. And post your answer in my comment box. Okay, I will see, and if you have any doubt, please post it. I will explain you in detail. Okay, right guys. Now let's see another application of the absolute configuration here. Yeah. Guys, here we have the another application of the absolute configuration, that is how to identify the identical compounds or the same compounds. Okay guys, very simple. For identical compounds, remember, for identical compounds, the absolute configuration at same chiral carbon atoms will be same. That means we have to take the pair of two compounds and give the numbering, identify the chiral carbons and give the numbering. At same chiral centers, if the absolute configuration, the two compounds are the same, those compounds will be, no doubt, they are the identical compounds. Here see, for example, in this case, just give the priority for all the compounds, guys. Here if you give the priority, okay, so which get the first priority? This is a chiral carbon, okay, this is chiral carbon 1 2, second carbon, this is first carbon, this is second carbon, first carbon is a chiral carbon here. So give the priority, nitrogen, carbon, hydrogen, oxygen atomic number is more, so it gets the first priority. Next nitrogen, next methyl carbon, and here it is. Now 1 2 2 2 2 3, how is our direction is rotating? Clockwise. So clockwise means R, where the fourth priority group is here, vertical is very good, so that means it is R configurated carbon. And here same as priority 1 2 3 4, so 1 2 2 2 2 3, okay, 2 to 3 is our direction is rotating in the anti-clockwise means S configuration. But guys, here see, horizontal is opposite now, so S becomes R. So this is also having the R configuration, this is also having the R configuration. So both are the two different compounds, not two different compounds, two isomers. Molecular formula is the same, but they are the two isomers. And in these two isomers, what kind of relation is there? Okay, at a given chiral center, okay, at a given chiral center in the two compounds, the absolute configuration is the same. That means these two compounds are the identical compounds. Like this, you have to identify the identical compounds. So in identical compounds, yes, the absolute configuration of the same chiral carbon atoms will be always same, whether the compound may contain one chiral center or more than one chiral center, but same as. Give the numbering first. After giving the numbering correctly, just find out the absolute configuration for all the chiral centers and compare the absolute configuration of the same chiral centers of the two compounds. Okay, in the two compounds, if the absolute configuration is the same at same chiral centers, those compounds will be always, yes, okay, identical compounds. Okay, let me give you one example for the sake of your practice, guys. So here I'm giving this example. So guys, identify whether these two compounds are the identical compounds or not. Again, I'm telling you. So in this case, okay, what you do is first give the numbering, guys. Okay, numbering to the carbon atoms. Here carboxylic acid is here, ester is here. Carboxylic acid gets the first number. So 1 2 3 4. Which carbons are the chiral carbons? Second carbon and third carbons are the chiral carbons. Okay, and here also give the numbering. How to give the numbering? Whether from the top to bottom or bottom to top. From carboxylic acid we have to start. Okay, 1 2 3 4. And which carbons are the chiral carbons? Second and third carbons. So second and third carbons are the chiral carbons. Okay, now right. Now what you do, guys, here? So give the absolute configuration first. Okay, and after giving the absolute configuration, the second carbon, third carbon, the same chiral centers of the two compounds. Okay, if the absolute configuration is the same, they will be identical compounds. Okay, so find out that absolute configuration and then see if the absolute configuration is the same. Okay, they will be identical compound. If at the same chiral center, if the absolute configurations are the exactly opposite, they will be enantiomers, as we discussed. So find out whether the pair of these two compounds are the enantiomers or identical compounds. Hope we can do this. Okay, now so do it and write your answer in the comment box. Okay, I will see that. If it is a right, that will be good. If it is a wrong, that will be very good. So why? Because we can learn what is correct. Okay, don't worry with your wrong answers. Okay, now right, guys, I'm here to help you, guys. Okay, right, now let us go to the one more and the last application. Okay, let us enjoy it, guys. Right. Guys, here see, now we will discuss how to identify the diastereomers. So what are diastereomers, guys? Diastereomers are the stereoisomers. They are the isomers. What kind of the relationship they have? They are having the non-superimposable non-mirror image relationship. Okay, the non-superimposable non-mirror images are called as they must be stereoisomers and they must have the non-superimposable non-mirror image relationship. Such kind of isomers are called as diastereomers. For example, guys, here see, I'm giving you one of the examples here. Here see, this is one of the compounds. This is also one of the compounds called as a tartaric acid. Okay, anyway, see here, carboxylic acid, OH hydrogen, and COOH. Here this is compound, and here also having the same formula. Na? Formula is the same. But guys, here see, whether these two are having the super mirror images. No, these two are the non-mirror images. And whether they can be superimposable on one or other, that means whether when you bring this compound onto this one, whether all the same groups are coinciding with each other. If they coincide, they are identical. If not, Okay, they are non-identical or non-superimposable. So here these two are having the non-superimposable mirror image relationship. They are the stereoisomers, they are the isomers. These are non-mirror images and non-superimposable. Such kind of isomers are called as a diastereomers. So these two are the diastereomers here. So then how to identify the diastereomers? This is simplest molecule. Okay, so how to identify the diastereomers, okay, in the difficult cases, and what is the relationship between the absolute configuration and the diastereomers? It is very simple, guys. In case of diastereomers, see, for few chiral carbon atoms, okay, at the same position the two isomers, I will tell you that. Okay, the RS configuration will be same, and at other chiral centers RS configuration will be opposite. For example, here see, guys, if you see this molecule, let's see how to assign the absolute configuration. This is second carbon, this is, okay, give the numbering 1 2 3 4. Here also give the numbering 1 2 3 4, and assign the absolute configuration. How to assign the absolute configuration? In this case, at second chiral carbon, consider this is second chiral carbon, okay, hydroxy group, carbon, hydrogen, and here is carbon. Oxygen atomic number is more, so it gets a first priority. Hydrogen atomic number is the least, it gets a fourth priority. And the next, these two carbons are there now. So this carbon is attached to one hydrogen, oxygen, carbon, and this carbon is attached to one double bond oxygen and another oxygen. Double bond oxygen means, according to multiple bond rule, two oxygens are there, so 2 plus 1 3 oxygens. So what happens here, more atomic number is there for oxygen, so it gets a second priority and it gets a third priority. So now view the molecule from the first to second, second to third. How is our I direction is rotating? First to second, second to third, our I direction is rotating in the anti-clockwise, and fourth priority group is horizontal. Horizontal is opposite, so generally anti-clockwise is S, opposite means R. So here in this case, second carbon is having the which configuration? R configuration. Don't write yes anti-clockwise. Why? Because horizontal is opposite. Okay, now, right. Similarly, let's see at third chiral center what absolute configuration is there. Okay, so at third carbon, guys, here see, hydroxy group is there towards right side, so right side first priority, and hydrogen is left side least priority, and carboxylic acid below the side, carbon is above the side. Carboxylic acid gets the highest priority, next highest priority, so it is second and it is third. So from the first to second and second to third, how is I direction is rotating? I direction is rotating in the clockwise. In general, clockwise is R, but fourth is opposite. Horizontal is opposite. That means R becomes yes. So 2R and 3 S configuration is there. Okay, same as in the given another isomer also, just find out the absolute configuration. So when you find out the absolute configuration here, guys, see, so at second chiral carbon, okay, na, hydroxy group is the first one, left side, hydrogen is the fourth one, right side, carboxylic acid second, and another group is third. So from the first to second, second to third is clockwise is R, but our fourth group is in the horizontal is opposite. That means R becomes yes. So here 2 yes, and this is at second chiral carbon, right? And for third chiral carbon, so for third chiral carbon, first priority, and this is fourth priority. And where is the second here? The second is at carboxylic acid is below the side, and this is third. Okay, first to second, second to third is in the clockwise means it should be R, but horizontal is opposite, so R becomes yes, so 3 yes. Okay, now, so we identified the absolute configurations now. Now guys, here see, at a given chiral center, that means in the first and second carbon at the same chiral center, here second carbon having the which configuration? R. Here second carbon having the which configuration? Yes. So means at same position means second position. Okay, at same position of two isomers, in the same two isomers at same position. Okay, the chiral centers having the which configuration? Absolute configuration will be same, and at other it will be opposite. So here these two are having the opposite configuration, and here this is third chiral carbon, absolute configuration is the same. That means few chiral carbons are having the same configuration and other few are having the opposite configuration. Such kind of isomers can be diastereomers. Okay, like this we can identify the diastereomers also. Okay guys, right. So this is the very easiest way to identify the enantiomers, diastereomers, and identical compounds, especially for the IIT entrance and AIMS level entrance exams. Okay, this is the most important thing, that is about applications of RS configuration. Okay guys, right. Guys, here I'm giving you one more practice example, okay, to identify the diastereomers, whether these are the diastereomers or not. Please, okay, find out the absolute configuration and identify whether they are the diastereomers and enantiomers are identical compounds. So for that, again, I'm reminding, so give the numbering. If more than one chiral centers are there, don't forget to give the numbering in the right way. So carboxylic acid, ester, carboxylic acid, first, second, third, fourth. Second carbon, third carbons are the chiral carbons. Here, carboxylic acid is below the side. Don't consider from the first to, okay, top to bottom. Okay, so here is the first carbon, next second, third, and fourth. Like this, you have to do. Okay, right, guys? So this is all about applications of absolute configuration. Hope, guys, you understand this and enjoy it. Do more practice. Practice makes you perfect. So guys, if you understand, if you like this video, please like it, subscribe my channel, and inform to your friends to subscribe it, so that they will also get benefit and they will also enjoy learning chemistry. Okay, guys, thank you very much.